Okay, so we're trying to find the area enclosed in between these two equations, and we find out that the bounds are between -2 and 3. Okay, so I'm going to first try to figure out these intersection points. The reason being is that it's going to change whether your area is positive or negative, and so you want to make sure that you create, or the reason you want to do this is because, for example, this one is top minus bottom, so the equation minus the x-axis, but this one is the x-axis minus the equation. So for cases like this, we kind of want to make sure that when we are finding the values that we know where to intersect. And so we're going to set the equation y equals x cubed minus 4x to the x-axis. And as you can tell, the x-axis is just when y equals 0. So we're setting these two equal to each other. So it's going to be 0 equals x cubed minus 4x. We'll use zero product property. So two products, you can set them separately to 0. So we got x equals 0, x squared minus 4 equals 0, x squared equals 4. So x equals plus or minus the square root of 4. So x equals plus or minus 2. So we have a point right here, -2, point right here, 0, and a point right here, 2. Okay, so let me move this to the side. Now we have to find the area between x equals -2, which fortunately is actually at one of our intersecting points. And another one at 3. This is 2, so 3 would probably be up here. And now we're going to color in or shade in the area that we're trying to find. So remember, we're doing it between the blue line and the red line, which is kind of hard to see, but it's the x-axis. So we have one little area thing right here, another little area thing right here, and then another little area thing right here. So in total, we're going to have 3 integrals. So we want to make sure this is why we want to kind of draw it. So let's start off with the first integral. We have it from -2 to 0. Now remember, when you're finding the area of between two lines, you want to take the top area, the top line, which is x cubed minus 4x, and subtract it by the bottom line, which is y equals 0. And because you're making a bunch of these tiny little lines from -2 to 0, the change in this is dx. So that's why we know that we're doing the top minus bottom. If it was the other way around, right minus left, your changes would be in y, and it would be dy. And in that terms, you would have to set the y's equal to integrals. So let's do number 1. 1 is from -2 to 0 of the top equation, which is blue. So that's x cubed minus 4x. And then we're subtracting it, remember top minus bottom, from the second equation, which is y equals 0. So in this case, it's just 0. And then remember these little differences, these little lines that we're creating, it changes by dx. So we're going to put dx on the outside. So let's actually find the integral. Oh, by the way, this is just number 1. So that's 0 to -2, x cubed minus 4x dx. That's x to the 4th divided by 4 minus 4x squared divided by 2 from 0 to -2. If you plugged in 0, it would just make it 0 because this is the numerator, that's the numerator. So let's just say 0 minus -2 to the power of 4 divided by 4 minus 4 -2 squared divided by 2. So we just plugged in -2. So we get 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. 16 divided by 4 minus 2 times 2 is 4. 4 times 4 is 16. 16 divided by 2. So that's negative 16 divided by 4 is 4 minus 8. That's negative 4. Negative is positive, so you get positive 4. So we know from here to here, which actually I should have not labeled it like that. Actually, it's fine. We know this area right here is 4. Okay, now we move on to the next part, which is from 0 to 2. So 0 to 2. Now this is different. The top equation is the y equals 0, and the bottom equation is x cubed minus 4x. So we're going to take the top equation, which is just 0, minus the bottom equation, which is x cubed minus 4x. Yeah. dx, because the changes are in x. So from 0 to 2, I'm going to distribute the negative sign. Negative x cubed plus 4x dx. And then we're going to go for the same integral idea. Negative x to the 4th divided by 4 plus 4x squared divided by 2 from 2 to 0. Now we're going to rewrite it to 2x squared from 2 to 0. And let's do the math. So negative 2 to the power 4 divided by 4 plus 2 times 2 squared minus, well, if we were to plug in 0, it'd be 0 divided by 4 plus 2 times 0, so that's just 0. Again, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So it's negative, remember negative, because the 4 is only going to 2. Negative 16 divided by 4 plus 2 times 2 is 4, 4 times 2 is 8. I guess I don't need the parentheses anymore. That's negative 4 plus 8, which is 4. So again, we have 4, which makes sense because we have x cubed, so they're probably going to be symmetrical. Yeah. And then this actually should be negative. I might have done my math wrong. Or, let me check something. So sorry. Let's see, 0 from 2, 0 minus blah, blah, blah. Okay, well, I'll have to check on that later because I can't recall if we are trying to find it in all positive values or if we're going to do it positive and negative. I'll look that up at the very end, but let's just say it's 4 for now, and then I will switch it to negative 4 if I figure that out later. Okay, and then let's do the last integral. So that's 2 to 3 because we are going from negative 2 to 3. So 2 to 3. The top equation is the blue one. The bottom equation is the red one. So x cubed minus 4x minus the x-axis, which is just 0. And again, we'll do the math. So x4 divided by 4 minus 4x squared divided by 2 from 3 to 2. Oh, sorry, 2 to 3 technically. X4 divided by 4 minus 2x squared from 3 to 2. Oh, I should have simplified before. Anyway, so then we're going to do 3 to the power 4 divided by 4 minus 2, 3 squared minus 2 to the power of 4 divided by 4 minus 2, 2 squared 3 times 3 is 9. 9 times 3 is 27. 27 times, oh my gosh, okay, sorry, let me just put it in the calculator. That's 81. Divided by 4 minus 2 times 3 times 3, which is 18, minus 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 divided by 4 is 4, minus 2 times 2 is 4, 4 times 2 is 8. Okay. So, that would be, if we're going to simplify this, it'd be 81 divided by 4 minus, and then we're going to multiply 18 by 4, so 72. And then that's just minus 8, negative 8 plus 4 is negative 4. Okay, 81 minus 72 is 9. So 9/4 plus, I'm going to change negative 4 to 16 over 4. And it's positive because there's two negatives. That's 25 over 4. So the last part is 25 out of 4. Okay, so we have 4, 4, and then 25 out of 4. Sorry, let me get a quick moment just to research about the negative area. Because that technically, that area is negative because it's under the x-axis. But actually, no, we would keep it positive. The reason being is because we're not considering the fact that, oh, it might be under the x-axis, so it's negative. Because we're trying to find the area enclosed between the two curves. So that if we were to just like ignore the axes, we're just trying to find the area between them. So it should, I believe it should just be positive. So let's add all of these up. It's going to be 4 plus 25 out of 4. So that's 16 over 4 plus 16 over 4 plus 25 out of 4. 25 plus 16 is 57 divided by 4. So that's your total area enclosed between the two curves of those two lines.